Hello. In this video, we want to look at an application. We want to find the linear velocity in meters per second for a particle that is moving in a circular path at 6 revolutions per second on a circle of radius 8 meters. Okay, now that we've read this, let's look at what we actually want. We want to find the linear velocity, and specifically in meters per second, for a particle that is moving in a circular path. We're told that it is moving basically at an angular velocity of 6 revolutions per second. And it's on a circle of radius 8 meters. Okay. Notice that we want the linear velocity of a circle, basically, of circular motion. So here, we've got a particle moving in a circular path. The radius of this circle is 8 meters. And the angular velocity, omega, is 6 revolutions per second. We want to find what is the actual, this color, velocity at any given time, basically. Now notice that the velocity is technically tangential to this at whatever point it is that you're looking at. So here, that's the direction of the velocity. Here, you would have the direction of the velocity be right there. Here, the velocity would be that way. Here, the velocity would be that way. So there you go. We want to find out what the magnitude is, though, because the actual direction is changing all the time. So to do that, we have to remember that our formula is V equals omega R, or R omega. I don't really care which one you use, because it really doesn't matter. But we have to make sure that our omega and R are in the correct units. Now, looking at the linear velocity, we want it in meters per second. That means that our radius needs to be in meters. Fantastic, it is. That's what we knew. That's what we wanted. Now, for the omega, which is in blue here, it is currently in 6 revolutions per second. Now, we want the omega to be in radians per whatever the unit is here for the time in radians per second. Well, the seconds are good, so we need to convert this from 6 revolutions per second into radians per second. So starting with our normal situation here, for every 1 revolution, there are 2 pi radians, and then just multiply straight across because the revolutions cancel. 6 times 2 pi is 12 pi radians. So this is radians per second. Good. And notice if you multiply meters times radians per second gives you meters per second, because the radians just kind of go away. So meters per second. And that's exactly what we wanted for the velocity. Good deal. Now just plug stuff in. So we have V is equal to omega of 12 pi. I'm not going to put the units this time. You already saw me do that. And then times R of 8. So 12 pi times 8. Well, 12 times 8 is 96. So this is 96 pi. And the units, of course, are meters per second. You know what? Let's do it this way. Meters per second. Just so that we're clear. Awesome. Good deal. Well, I think I'm going to go ahead and end the video here, and I will see you in the next one. Have fun.